Mic check, mic check. Am I audible? Welcome to another video on the Bitcoin Developers channel. I am your host Connor. Hope you're doing well today. So today we're going to talk about human readable Bitcoin addresses. If you've ever tried to send a truly peer-to-peer transaction on the Bitcoin network, you'll know there are a few UX pain points, or I'm sure you've come across a few pain points when trying to do this. Typically we have to, if we're with a person in person, we'll scan a QR code, or if not, we'll copy and paste around these long alphanumeric hexadecimal strings. And oftentimes this can be quite error prone, leaving users with strong sense of fear whether or not they've sent the right payment information to be able to receive funds and stuff. So this has been identified across the ecosystem, and a few efforts have been put forward to try and resolve this by providing people with a mechanism that they're more used to. So the end result is something that looks like an email address, which you can pass around to different entities and receive Bitcoin that way, which is an experience probably more people are accustomed to. So today we're going to talk about specifically BIP353, BOLT12, DNS, and being able to set up a human readable Bitcoin address that is self-hosted. But we'll also talk about what that might look like for third parties as well. So by the end of it, you should be able to see it in action and see how it actually works on the ground. So let's jump in. So the first tab I've got open here is the Bitcoin design community. So if anyone's not familiar with the Bitcoin design community, it's an free open source community that's focused on tackling some of the challenges that we see when using and building Bitcoin products and applications. Like I just alluded to, there are a number of different experiences that can be smoothed over, let's say. And this community is focused on trying to help solve some of those challenges. So it's a community of designers and researchers and artists, different types of people of that nature who are focused primarily on that. So one of the flagship projects that community has worked on over the last, let's say, 3.5-4 years or so is the Bitcoin Design Guide. This is what you see on the screen now. And the Bitcoin Design Guide is designed to be a guide that gives any builder, any product team a set of tools and guidance on how to tackle specific UX problems. If I click here on the guide, you'll see a lot of information on how to get started designing Bitcoin products from scratch, and then different types of products that you might want to build as well, whether it be the use case be for daily spending or a savings use case or inheritance. There are different types of use cases emerging. The community tends to collaborate with already existing open source Bitcoin projects as well, so you can read a little bit about the case studies and some of the work that has gone on over the past couple of years. But let's dive into the human readable stuff. So let's see what the guide says in this first paragraph here. So Bitcoin addresses and payment requests are long and cryptic, practically impossible to read, memorize, pronounce, understand, or type. We are used to being able to communicate our social media handles and email addresses easily. That expectation has also extended to transacting with neobanking and payment applications. There have been multiple attempts at making human-readable addresses a reality in Bitcoin. And some of the benefits of the user experience include familiarity, a format that feels more human and familiar to users, and ease of sharing, a format that is easier to remember, recall, and share. So one of those attempts is BIP353, which uses DNS payment instructions to resolve Bitcoin information, essentially. So let's go even higher level. Let's look at what the kind of end result of what a Bitcoin address will look like for us. Let me see if I can zoom in a little bit here. Just zoom in a little bit. Make that a bit clearer. Yeah. So here you can see we have this email-like looking address or format. So it's prefixed with the Bitcoin icon, some username, and at domain that you may own, or it could be, a third party as well. So very similar to how emails look. And how it works then is that users create DNS entries with payment information, which can be one or more addresses. So we're going to talk about what the underlying address formats are going to be for this BOLT12, and you could also use silent payments. Or a combined kind of BIP21 URI, which is a long string which can consist of both of those things. And it's designed to be used for addresses that are reusable. So as you can see here, a wallet or some service can type in this Bitcoin address, and they reformat it to and it essentially gets reformatted to a DNS text record, which I'll explain a little bit more in detail a bit later. And then it does a DNS lookup, which will ultimately surface or resolve the Bitcoin information. So this is your Bitcoin URI. The Lightning offer will look like this: LNO equals, and then you have your BOLT12 offer, and then a similar thing occurs for silent payments as well. So let's talk a little bit more about BIP353 or BIP353. Sorry. So this is a Bitcoin improvement proposal that was put forward by Matt and Bastian, and you can read the details a bit more here. But the kind of motivation behind this was various types of Bitcoin applications and other cryptocurrencies for that matter have kind of adopted this kind of human readable payment instruction format. And so it has signaled pretty strong demand from users in the space, and it seems to be something that users are comfortable with at this point. But this proposal uses DNS and DNSSEC. So DNS is like the global naming system for how we interact on the internet, essentially. So when you type in, I don't know, google.com, for example, DNS is responsible for resolving that to an IP address, and DNSSEC is just maybe a layer on top that enables you to kind of cryptographically sign any information related to your DNS records. So you can read a bit more about the BIP here. I'll link to that in the description as well. So we have this way of using this kind of global piece of infrastructure that already exists and is already quite established on the internet to resolve different types of Bitcoin information, different types of Bitcoin addresses. I did want to touch a little bit about what are those pieces of information that are going to be stored in your DNS records. So one of those is called a BOLT12 offer. BOLT12 is really an important piece of technology within the Lightning Network. And I just want to talk about it in the context of cash for a quick second. So this is a slide from a presentation that our friend Steve did about a year ago, just highlighting the importance of cash in any kind of freedom orientated payment system. Cash has many important qualities. For example, if you want to hand over a $5 bill to purchase something at the shop, for example, you don't need to fill out any paperwork. You don't have to KYC. You don't have to ask for permission. You don't have to worry about the transaction settling. There's no third party involved, and the transaction is private and secure. It's just between you and that individual. But over time, we've kind of moved to and transitions to this digital kind of form of money. So some of those properties have basically been lost, and a lot of people might not recognize this now, but it will become more apparent in the future. So Bitcoin was invented to solve some of these problems. It is supposed to be a freedom money for all, and so Lightning Network is designed to facilitate that along with instant payments. Let's see here. So we've got kind of BOLT11, which is the original Lightning Network payment protocol. And it's pretty ubiquitous across the whole ecosystem at the moment. But it does have a few drawbacks in that invoices can only be used once. So typically you provide the sender an invoice and they will be required to fulfill that payment. The QR codes are quite long, maybe making it difficult to scan on certain types of devices. It has poor privacy because the recipient's node ID is contained or included in the invoice material as well, and there's a necessary interactivity requirement when actually trying to do payments, in that the receiver has to generate an invoice before they can be paid. So there are a few drawbacks. So yeah, I mean, if you've ever kind of played around with paying Lightning and BOLT11 invoices, you might have seen some of these errors pop up before. So we do have a solution currently out there, and that has solved quite a few of these problems. LNURL. So LNURL is a protocol that introduced this notion of a web server to allow reusable payments. So a server can essentially issue a new invoice every time one is needed, which is fantastic for UX and having reusable invoices, especially if you want to do things like get tips or just be able to receive funds 24/7 basically. And this is an awesome update on the usability of Lightning, but it does impact some of the core components and some of the main value proposition of Bitcoin, one of which is censorship resistant. So by law, I guess, certain servers can only allow payments from certain jurisdictions. So it's pretty poor from a privacy point of view. Servers can essentially learn who is paying who by how much and log that information potentially. And even if the company doesn't have any ill intent, it does represent like a honeypot for hackers to go and try and retrieve certain information and potentially de-anonymize certain people, which is, it's not what we want. So, and then on top of that, there are a few security concerns as well. So servers issue the invoice on behalf of the user, right? So there's nothing stopping a server from issuing an invoice that pays someone else. And yeah, I mean, they probably won't do this in large amounts, but maybe it's something that is a slow burner type of attack. So it could be very small amounts over long periods of time, thus rendering it difficult to detect. So there are a few angles of attack there, I guess. So we're going to talk. So BOLT12 is one of the ways that you can natively generate a reusable Lightning address or Lightning invoice, and it offers superior privacy, censorship resistant, and privacy improvements as well. So let's see here. What do I want to go into this as well? BOLT12 features. So the offer is the main thing that is kind of underpinning BOLT12, and it allows you to generate a reusable QR code or reusable payment code that you can use everywhere. And it's not one-time use essentially. Okay, so let's so yeah, I didn't mention LNURL. So this is like the Lightning address, which is built on top of LNURL, which you might have seen in many different applications. So what we can do now then is let's actually try to create our own human readable Bitcoin address using this BIP353 scheme and BOLT12 offers. Yeah, so what I'm going to do, there are a number of different implementations, Lightning implementations that support BOLT12. Everything from LDK. I did a video on LDK, the Lightning Development Kit project, is the last video I did. So if you want a refresher on that, please go and watch that. So we've got Lightning Development Kit. We've got Phoenix or Async. Phoenix support BOLT12 as well. We've got Core Lightning. And we also have LNDK, which is an important project that adds a separate, that uses LDK alongside LND in a separate process that allows you to, that supports BOLT12 by enabling onion messages and the ability to pass BOLT12 offers and invoices. But for the purpose of this video, we're gonna use Phoenix D because I think it's pretty easy to spin up, and I've already got like an instance running in a cloud on a cloud provider as well. So we're gonna do that. We're gonna do that. Okay, so I think the first thing I'm gonna probably try and do is I'm gonna grab a copy of Phoenix D from GitHub. I'm gonna find a build that is compatible with my machine. Let's see here. I think if I click releases, is it releases? No, I think if I click, let me go back. I think if I click releases here and I scroll down, so yeah, I can find the instance that's compatible with my machine. I'm on a Mac OS at the moment. So what I'll do is I'll open a terminal. Let me make this a bit bigger for you guys here. And then I'll cd into a project folder. I keep most of my projects, and let me just see if I've got it in there. So yeah, so I've got Phoenix D here. I think if I unzip it using this command here, so I'll unzip it. I can actually follow the instructions that have been outlined on the Phoenix D website, and then basically just run the daemon. So I'm just going to run it from my terminal here. So let's see. You can, okay, so Apple's moaning at me because I'm running a piece of software from a non-verified source. So let me just make sure I can run that by going over to here. I'm going to allow anyway, and I should be able to run it now. I'm going to open anyway, and I'll use my password to open it. All right, cool. So we've got Phoenix D running just on my machine locally. Got a bit of information here, node ID, auto liquidity. So I believe this is if I try to deposit some sats to this, some Bitcoin to this node, I automatically get what is that? 200,000 worth of sats as inbound liquidity, my node ID, and then my offer. So this is the long numeric string that we was referring to earlier, called the BOLT12 offer, and this is used to fetch a Lightning invoice using onion messages and blinded paths. So onion messages are an encrypted messaging layer on the Lightning network that provides very good privacy benefits when routing payments. And then blinded paths make it such that the sender of the payment doesn't know the recipient's node ID, which is pretty cool. It does this using something called an introductory node, I believe. But for the purposes of this, we don't really need to know that. So if you're following along, you're going to want to make a copy of this offer, because this is what you're going to use and paste into your domain name record, or domain name record, essentially DNS record. All right, so we've got our node running. We're finished with Phoenix D. If you don't want to, we're running it locally here. I also do have an instance running on Nodana, so they provide cloud hosted Phoenix D instances as well. So if you want to spin up a instance in the cloud and kind of have that running 24/7, you can do that here as well with Nodana, which is pretty cool. But anyway, I'm gonna show you what this looks like from a domain register called Cloudflare. I used Cloudflare because let me see if I can make this a bit bigger. I used Cloudflare because they have DNSSEC, the ability to turn on and off DNSSEC quite trivially. I think it's just a push of a button basically, and it will turn it on and do all of the DNSSEC setup for you, so you don't have to worry about that. And then you're required to, depending on what your domain registrar is, assuming you have a domain name, you're required to add a TXT record, and the format is type TXT, and then you want to, the name portion of the record, you want it to be, let's go back to what the design guide had for us. So you want to have some username. So in my instance, where am I? In my instance, I've called it pay is the username in this instance, and then the rest is user._Bitcoin-payment. So this is what we are basically seeing here. And then the value or the content of the record, you want to have, this is where you paste in your Bitcoin URI. So it's almost like a, it's, what does it sound, a uniform resource indicator. So it's kind of like a URL, I guess. Let's see if I can make this a bit bigger as well. So in this case, I'm only going to use a BOLT12 offer. So I paste in Bitcoin, :LNO, which is the human readable part, equals LNO1, and then this long alphanumeric string. So that's what is required that you copy from your node, which was generated for me in this case from Phoenix D. So I already have all of that set up, and then you just save that into your records. If you want to understand a bit more about DNSSEC as well, Cloudflare actually have a really good article about it actually. So here it says the domain name system is the phone book of the internet. It tells computers where to send and retrieve information. Unfortunately, it only accepts any address given to it, no questions asked. So it tells you a little bit about the kind of cryptographic guarantees you can achieve by using DNSSEC. So I'll link to that in the description below as well. All right, so I have a human readable Bitcoin address called, let's go back. I'm going to go to this quickly. So what this will, I have a domain name called connorocus.cash. And by setting up this TXT record, I have generated a Bitcoin address, human readable name, called pay@connorocus.cash, essentially, is what is the resulting Bitcoin address. Now, if we want to just make sure that's working, there are a few tools we can use. So Matt wrote us this really nice tool called BIP353 resolver, and you can also use this if you're building a Bitcoin wallet and you don't yet have a way to resolve BIP353 names natively. This site will resolve it for you. But in future videos, we're going to look at some code and how to actually implement it in an application or in a wallet. So I will, let's see if I can actually resolve my Bitcoin address here. So it's pay@connorocus.cash. Got my 1% Trezor opening for some reason. Anyway, so it worked. Pay@connorocus.cash was successfully resolved to the following address. Your wallet should have automatically opened to pay. Oh, okay. I guess that's why Trezor was opening. But here you can see, here is the BOLT12 offer that I pasted into my DNS records. And then last one is 12.cash, which allows you to also resolve your Bitcoin address if you want to check that it's working as well. So I'll do it here as well, just for giggles. Not donor. connorocus.cash. Check pay code. Let's go. Yeah, so it's got my pay code there as well, and it's got the BOLT12 offer that was generated from Phoenix D as well. Cool. So pretty easy to set up. Let's actually test it working in action. Let's see if I can actually make a payment. So I mentioned earlier, I've got my node that's actually running in the cloud with no Dana. So I'm going to use that node instead. So let's see here. I have an alias for this. So I think I called it PD, which is Phoenix D, and get info. So this should just make a basic curl command to my Phoenix D instance running in the cloud. And it just returns that node's information. I've got 27,638 Satoshis in there, and this is the amount of inbound liquidity I've got. What is that? That is just over 2 million Satoshis, I guess. And this is running on mainnet. I can do get balance to show my balance. I guess it's the same thing anyway. Yeah, cool. So let's do that one more time. So get balance. So 27,638. So what I'll do is I'll attempt to open a wallet, provide it my Bitcoin address, and send some sats to it and see what happens. Right, so I do have a simulator open. Is it this one? Yeah, here we go. Nice. So this is the Phoenix mobile wallet. I think that's I think the visuals on that is fine. So I've set this up already. I've got 2,514 sats there. So let's try and, I wonder if I can do it like this. Yeah, let's try and maybe do that so you can kind of see it on both screens there. Yeah, let's try it that way. So I'm going to send So I'll paste in my, or I'll type it out. I'll type it out my my Bitcoin address. Connor. Oh, maybe because I'm using a simulator, it's not picking up my my keyboard very nice. But no worries. We'll quickly just type it in on the simulator keyboard here. At nope, that's not what I want. Dot cash. Yep, that looks right to me. Let's just send over, I don't know, 100 sats, yeah, 9 cents, and click pay. I didn't add a description. Maybe I should have added a description actually. But anyway, you can see the payment has gone through. So 100 sats and minus 4 sats in fee, and if we go here, LN01 ZRXQ8 is the same offer. So it's managed to successfully resolve the offer that I have in my DNS records, which if we go back, you can see here ZRXQ8 and then ZRXQ8. So let's check the node and then see if it actually made the payment, I guess. So I'm starting balance of 27,638 and the moment of truth is a balance of 27,738. So yeah, worked quite successfully there. So yeah, this video is a bit longer than I was hoping it to be or expecting it to be, but I hope it was easy enough to follow, and you could see how kind of easy it is to set up a self-hosted Bitcoin address. In future videos, so I wanted to put this out there because it's going to be a nice springboard for future videos. So future videos, we're going to actually show some cool use cases of this in action. One of them I'm really enthusiastic about is being able to receive tips via like a live stream on Twitch or on YouTube or something like that. So what you'll see is a BOLT12 offer displayed as a QR code on the screen, as well as the human readable address. You can have both, and then as you're streaming away, viewers can be tipping you sats. And the cool thing about that is if you're using something like OBS allows you to write custom scripts. And so if you have there's many ways you can do this, or there's a few ways I'm thinking you might be able to do this, but you can run an instance of Phoenix D locally on your computer and then create some kind of Python script. So OBS uses Python to interact with that node and be notified when you receive payments and have certain things appear on the screen when a payment is received. There is already a project that I've been experimenting with called BOLT12 tips. So I'm going to go through this or showcase it in a future video. But yeah, it's basically just a small demo project that allows you to stream sats while you're playing games or while you're doing tutorials or whatever it might be. So that's pretty cool. So I'm gonna show that off in a future video. And it's cool. Yeah, it uses BOLT12. I don't think it has support for silent payments yet. We didn't talk about silent payments much, but we can do that in a future video. But yeah, I hope that was easy enough to understand. I hope you enjoyed that. If you have any questions, leave your questions in the comment section below. And yeah, I'll see you in the next one. Peace.